and government agencies, helping them to utilize standards and adopt additive manufacturing. With more than 14 years of experience on additive manufacturing processes and materials, he received a total of 10 awards and patents in the area of additive manufacturing. He is active within the additive manufacturing community and continues to review and publish journals, as well as making technical and business presentations in Asia. Let's welcome Dr. Alex Liu.
Hi, morning everyone. Let me share my screen. Please let me know if you see the screen. Can everyone see the screen? Okay, great. So yeah, good morning everyone. My name is Alex. I'm from Astm International, based in Singapore, and very happy to have to be in this event today, this morning. So my topic today is on navigating the global additive manufacturing standards landscape. So a very quick introduction about myself. So I have an undergraduate degree on robotics and automation, and I did a PhD in additive manufacturing with a focus on process and materials since 2007. So the outline today will be on about ASTM, followed by about F42, and then about our Center of Excellence. And fourthly, I will share the navigation revolving the global AM standards landscape. And finally, an insight, what does the future hold? So firstly, about ASTM. Now, ASTM is a 120-year-old organization, and we have about 140 over technical committees, and these committees host 30,000 committee members representing more than 150 countries. Together, they have developed 12,800 over standards that cover 90 over industry sectors. And as of now, we have about 100 over global MOU partners, Philippines included. One interesting fact is that 60% of our revenue comes from outside of the US. Pennsylvania. We have offices in Washington, D.C., Europe, Canada, South America, and very recently, Singapore. So we have accreditation from American National Standards Institute and Standard Council of Canada. And really what we do here is a common sense approach that is heavily driven by the industry and also a consensus-based approach. So we work over a century of openness. We provide. Let me end the show and see what's happening. So we provide the infrastructures and tools, as well as bringing the industry together. I'm so sorry about that. Just give me a minute. Okay, let me do it this way so it doesn't run, all right? So over a century of openness, we provide the infrastructure and tools and bring the industry together to develop standards. One thing I wanted to highlight here is that the staff does not write the standards. The ASTM staff remain neutral and the standards development activities are driven by our members. So there are many different types of standards today. There is a company standard, there is consortium standard, industry standard, government standard, as well as voluntary consensus standard. So ASTM sits here. Consensus is developed by representatives of all sectors and they have an interest in the use of standard. Okay, there's a use of standards. And there are different standards being cited in the US regulations, the Code of Federal Regulation. You will see that there are many different standards development organizations. ASTM International is the #1 standards development organization that has more than 2,300 in the CFR. So one quick overview about our ASTM membership. You can participate in our standards development activities by being an individual member, organizational member, or informational member. So if you're a student, membership is free. So secondly, I will share about our F42. So a quick view about our F42. ASTM established the F42 committee in 2009. Today, we have close to 1,000 members, out of which 20% comes from outside of the US. At this moment, we have 36 approved standards and 7 under development jointly with ISO. And I will share a little bit more about our collaboration with ISO in the next few slides. We meet twice a year, once in the US and once out, and the second one is out of the US. Right now, because of the pandemic, the past 2 meetings, or rather the past 3 meetings have been virtual. And we also have global representation including the following countries listed there. I'm very happy to say that Philippines is one of them. This is our subcommittee focus: test methods, design, materials and processes, health and safety, applications, and data. This is our meetings overview. In 2016, we were in Japan. 2018, we were in Singapore for Asia region. This is actually invited by the government there. Last year, we were invited by the South Korean government, but because of the pandemic, we couldn't go there. Hopefully, we'll be there this coming year. So this is our F42 committee structure. It starts with a main committee, followed by the subcommittee. So an example would be F4207 applications. Under each subcommittee, there will be a subsection. So another example would be F420705 on maritime. I highlighted the applications and data subcommittee because I wanted to highlight them to share with you that these 2 subcommittees are newly established in the past 2 years. And this is the subcommittee structure. Example would be the F4207 applications. And ASTM recognizes the growing need in this industry. I mean, a lot of activities are driven by the industries. So again, the highlighted box there is on energy. So this is the new subsection that is established under F4207 that specifically looks at developing standards for AM in the energy sector. In terms of ISO and ASTM partnership, so a little bit history. I shared earlier on the ASTM F42 started in 2009. ISO TC261 started in 2011. Very soon, we realized that a lot of standards development activities are overlapping. So for that reason, we came to a collaboration. We signed a partnership standards development organization, in short, PSDO cooperation agreement in 2011. Today, we have 36 published standards and 70 over standards that are under development. So the third session is about our Center of Excellence. So to give you a little bit understanding is that standards development has its own challenges. Standards development is a lengthy process. We need to have solutions to keep up with the rapid pace of the AM technology development. As you know, AM technology is evolving at a very rapid pace. So for this reason, what happens is there are standards gaps, there are duplication of efforts, there is inconsistent standards and R&D across different industries globally. There is also no dedicated workforce to drive R&D for standards development. There is also lack of, I like to use the word, a severe lack of global acceptance of standards. So how do we overcome all these standards? The answer is the Center of Excellence. So Center of Excellence, ASTM AM Center of Excellence is a center that we work with different partners, for example, Auburn University, NASA, EWI, MTC UK, NIA, and NAMIC in Singapore. With all these partners, we conduct R&D projects that can accelerate standards development. So we have demonstrated some level of success in this aspect. For example, a standard can now be developed anytime within 12 to 18 months. It used to take probably up to even 36 months. So with that, we are able to shorten the time spent on standards development. So these are our partners that I mentioned earlier on. We request for proposals in 2017. 2018, we have our founding partners, NASA, Auburn, and EWI. And in May 2018, we have MTC UK that joined us. And August 2018, we have NIA, which is the National Institute for Aviation Research in the US. And finally, in October 2018, we have NAMIC to join us as a strategic partner. So these are all our AMCOE locations. In total, we have about 100 people involved in our Center of Excellence activities. So in terms of our Center of Excellence, these are our 4 pillars. We focus a lot on research and development because we strongly believe that we can leverage R&D to significantly accelerate standards development. And then we have education and workforce development. We have standards and certification, and finally we have industry consortia. So for R&D, how it works? Firstly, we have direct funding from ASTM, from the government, as well as from the industry consortia. And then our partners, COE partners, will then plan the R&D, followed by conducting the R&D, and then benchmarking materials in terms of standards development, processes, testing, as well as machinery for standards development. Finally, implementation, where the industry can utilize standards to develop certification or qualification programs to certify or qualify facilities, products, and operators. In terms of high priority areas, it is linked directly to our subcommittees. So for example, if you look at design, data, and modeling, it is really linked to all the different subcommittees like test methods, design, materials and processes, and applications. In fact, in the Additive Manufacturing Standardization Collaborative Roadmap, they have identified a total of 93 AM standards gaps. And they categorize into high priority, medium priority, and low priority standards gaps, out of which 65 requires research, and ASTM is already positioned to address all these gaps in conjunction with ISO. So navigating the AM standards. So standards, why do we have AM standards, right? So standards are key for AM industrialization. Standards can ensure process control. It also increases the product quality assurance, and it allows us to define different levels of criticality for different applications. So for that reason, we are able to then reduce the risk as well as reduce costs. And this will help to facilitate larger adoption, right? As long as cost comes down, the adoption will increase. Standards also impart trust and build confidence. And standards can be used to develop certification and assurance programs, which eventually are being utilized to qualify or certify parts, applications, as well as products and services. The current standards development landscape for additive manufacturing, already a number of standards have been published by ASTM and ISO. There are about 37 of them right now, and 77 standards are currently under development. So there are 5 different categories of standards that I listed here. There is a general AM standards. There is application-specific standards such as for aerospace, medical, automotive. There is also feedstock material standards. There is process and equipment-related standards. And finally, there is finished AM part standards. So this is a snapshot of our ISO ASTM standards. It is done by David Heddercry from MTC UK. He has categorized this into terminology, different categories, and color-coded them. So purple ones are standards that have been published. The green ones are standards that are available as a draft. The blue ones are working documents, and gray ones are cancelled. So what are the other standards development organizations? So ASTM and ISO are the leading SDOs. And of course, there are also other SDOs involved in this effort. There is ASME, SAE, APAI, as well as UL. So for example, SAE has a SAE AMS 7000 series that is focused on aerospace applications. API stands for American Petroleum Institute. They have this API 20S standard that is focused on oil and gas industry, on additive. And UL, there is a UL 3400 AM safety standard. The other category would be an NSB. NSB stands for National Standards Body. So there is DIN that is working on standards for Germany. AFNOR is for France. BSI is British Standards Institute that develops standards for the UK. And for example, another example would be Singapore, Enterprise Singapore, that develops standards for Singapore. So in terms of global standards, we recently published 2 volumes. Volume 1 is on published standards, standards that have been published, and volume 2 is on standards under development. So these are all available under the ASEAN AM strategic guidance document, which we developed with the ITA in the US. And we, for both volumes, we categorize into 4 different groups. So there are joint standards, there are ISO standards, there are ASTM standards, as well as other standards. So in the interest of time, I will only share a few examples from Group 1, joint standards. So these are 3 examples of joint standards, ISO and ASTM, on terminology, design, and metallic powder characterization. Another example would be ASTM standards. And under these ASTM standards, the subcategory, there is AM specific standard. What we mean by that is that we have developed standards by the F42 that's specific to AM. Another subcategory is that for AM specific standard, we also develop standard AM specific standard by other committee. For example, EO7. EO7 is the committee for NDE, and they also develop an AM standard that is specific to metal AM aerospace parts. The third subcategory would be standards applicable to AM. So for example, we have a BO9 committee that focuses on powder standards, metallic powder standards. And these are standards that are developed a few years ago or many years ago, but they can be applicable to AM. So for example, we have B213 and B214 that is on flow rate of metal powders and sieve analysis of metal powders respectively. So these standards, they are developed by other committee that may not be specific to AM, can be applicable to AM in terms of powder characterization for quality assurance. Some key recent key standards. We have the 52901. This is the general principles requirements for purchase AM parts. One of the most popular ones in the standard. If you have the opportunity to download it, you will see that within the standard there is a list of selection criteria that can be agreed upon between the sellers as well as the buyers. Another standard would be practice for metal powder bed fusion process to meet critical applications. And of course, there is a machine-specific standards, operator standards, as well as installation, operation, and performance standard that is focused on production. Other key standards in development, under the feedstock category, there is technical specifications on metal powder. And you will see that in this standard, standard that is going to be published soon, you will see the different references that we cite from B09, which I mentioned earlier on. There is also a new guide for quality assessment of metal powder feedstock characterization data specific for AM. There is also test standards. There is test artifacts, tension testing of metallic materials. This is about a standard guide for creating miniature tensile coupon for AM. And then there is also NDT as well as in-process monitoring, a standard guide for in-situ monitoring of metal AM aerospace parts, as well as a new practice, or rather a guideline for NDT of AM parts. So I come to my last section about what does the future hold. So in terms of technology readiness level, we listed a few industries here. We have aerospace, tooling, automotive, and medical. You will see that at this moment, aerospace TRL is about a level 5 to 7. Tooling is 9. Automotive is 4 to 5. And interestingly, medical is 9 to 10. It is already full rate production. And there is also low rate production. So you can see that the adoption of AM technologies also depends on the industry. Some industry can adopt at a faster rate. Some industry not really. So some examples in the automotive industries that we see are some of the opportunities here. For example, BMW have been printing roof bracket for their vehicles. We have General Motors also featuring a seat bracket that is topology optimized. We have Michelin, who did the tire sipe applications. So what happens is that they design the tire sipes, they put it into the molding, into the mold to mold the tires. And then there's Burgundy that has printed an 8-piston monoblock brake caliper that has shown to withstand high temperatures during a race. So in terms of the railway industry, there is also a lot of opportunity. We are starting to see a lot of examples. For example, Siemens Mobility, they optimize the spare parts with AM because AM is slated to also address digital inventory, right? Then there is also Angel trains, eliminating the obsolescence of parts. Also, GE Transportation is looking at on-demand manufacturing to reduce physical inventory, and Deutsche Bank, who is also AM production and maintenance using additive manufacturing technologies. So in terms of challenges and opportunities in AM adoption, in the past, AM is very high cost. AM is very low production. And presently, we have seen that the costs have reduced a lot and the speed has increased. So for example, the first AM machine that I bought has only 1 laser. The second one I bought has 2 lasers. And then very quickly, you see there are 4 laser machines in the market. Up to now, they are even talking about 8 and 16 lasers. So the speed, or rather the rate of production for AM has increased tremendously. So in future, some of the standards development, in future, we are looking at standards development that can facilitate larger adoption, bring confidence, build assurance, build confidence, and allow certification and assurance of AM parts. So before I end my presentation, I wanted to share with you what are some of the opportunities to participate in some of the global AM activities through ASTM. These are some of the selected past events, some selected upcoming events, as well as webinars. We are also hosting our International Conference for Additive Manufacturing, ICAM. This is our annual flagship event. Very happy to have people from the Philippine community to also participate in ICAM. So with that, I end my presentation and I'm ready for Q&A. Thank you. Back to the host.
So it seems like there are no questions from the audience, Dr. Liu.
Okay.
Okay. We would like to thank you for your presentation, and we would like to present this certificate of appreciation. So this certificate of appreciation is awarded to Dr. Alex Liu for imparting valuable knowledge as a resource speaker during the ASEAN Conference on Additive Manufacturing 2021 with the theme 3D Printing, Revolutionizing the Manufacturing Industry, held on October 28 to 29, 2021. Given this 29th day of October 2021 at the Dusit Thani Hotel at Makati City, Philippines, to be signed by Engineer Marianito T. Margarito, the conference chairman of ACAM 2021, and Dr. Annabel V. Briones, the director of the Industrial Technology Development Institute.
Thank you.